in this question, we have a woman of 52 kilograms, and we have a man of 72 kilograms, and they're standing 10 meters apart on the ice. And because it's frictionless ice, that means this is an isolated system. The center of mass position will not change. So firstly, we ask how far from the woman is their center of mass. So this is we just calculate Cm equals mass of woman of distance of woman plus mass of man, distance of man, over mass of woman plus mass of man, because we're asking how far is from woman, so x of woman is 0. So we have 72 kilograms, the mass of the man, times 10.0 meter, the distance of the man from the woman, and 124 is 52 plus 72. So this gives us 5.8 meters. So the center of mass is a little bit closer to the man because the man is heavier. It's 5.8 meters. Okay. So now what happens is that there will be a rope between them. They will both pull on the rope, so they move closer to each other. And we ask if the man moves a certain distance, how far the woman will be moving. So there are a couple ways we can do this problem. I feel like the easiest way is if we switch to the coordinate of the center of mass. What that is that we previously have our origin at here at the position of the woman. If we now switch our position, so we now take our center of mass as our origin, then what we see is that the x center of mass in this coordinate will be 0 because center of mass is our origin. But what that also means is that because, so I'll do this line. Previously, this is 5.8 meters. This is from the woman. But now I'm taking center mass coordinate. So what that means is because the center of mass, I just call it prime to indicate that it's a different coordinate. Because x center of mass, it has to be 0 because that is our origin. What that means is that the mass of the man times the distance of the man, the mass of the woman times the distance of the woman plus the mass of the man times the distance of the man over the mass of the woman plus the mass of the man has to be 0. So that means whatever is in numerator has to be 0. So what that means is that the mass of the man divided by the mass of the woman is the mass of the man divided by the mass of the woman is opposite to the distance of the woman divided by the distance of the man. So, or because you can see that the mass of the woman times the distance of the woman is negative the mass of the man, the distance of the man. So we have this relationship over here, and we can add absolute value here. So now, yeah. So here, the negative sign pretty much means that they will be moving in opposite direction. So if the man moves towards, if this is the x direction, and the man moves in negative x direction, then the woman will move in x direction. So if the man is closer to the center of mass, so will the woman, and the other way around. If the man is going away from the center of mass, so will the woman. So the good thing about this is this gives us a relationship of the distance that man and woman will be moving with respect to the center of mass, and it gives us this ratio in terms of the mass. So what it means is that if the man, because the man has 72 kilograms, the woman is only 52 kilograms. So if the man moves towards the mass by 5.2 meters, that means the woman will be moving to the center of mass by 7.2 meters. So with that, it makes our subsequent questions a lot easier. Now we ask if the man pulls on the rope so that he moves 2.5 meter, how far from the woman will he be now? So if the man moves 2.5 meter, so if the man, he is originally around 4.some meter, and now he moves here by 2.5 meter. And the woman will be moving here too as a consequence of him pulling the rope. So now we need to find this distance. So the distance the woman moves will be mass of man over the mass of woman times the distance of the man. So that is 72 kilogram divided by 52 kilogram times 2.5 meter. So that is 3.46 meter. Now we ask how far are they from each other? Well, so then it's just 10 meters, the x original, divided by the x of man. The distance between them. The distance between the man and woman is the original distance divided by minus distance moved by the man is the distance minus by the woman moved by the woman. So it's 10 meters minus 2.5 meters and 3.46 meter. And again, we only need two significant digits here. So this gives us 4.0 meter is the distance after the man moves 2.5 meter. So the last question is, how far will the man have to move when he collides with a woman? So that happens when xw plus xn, and the distance they move in total is 10 meter. But at the same time, we know this ratio. We know x woman equals mn over m woman times x. So if we plug this into the previous equation and we organize it a little bit, we will see that the distance moved by the man is equal to the total distance divided by their total mass times the mass of the woman. So it's 10 meter divided by 72 kilogram plus 52 kilogram and divided by times 52 kilogram. Okay, and this gives us 4.2 meter. So in order for these two people to be together, the man has to move 4.2 meter. And because he pulls on the rope, the woman will be moving towards him for the rest 5.8 meter. So that is actually this the last question might be even easier if we consider that when they collide, they will both be at the center of mass. So since the woman is originally 5.8 meters from the center of mass and the man is originally 4.2 meters from the center of mass, then the man will have to move 4.2 meters so that they could both be at the center of mass. So that is a little tricky. That's a shortcut to get the answer.